Now, if we do butane, that's a different story altogether. So butane has 4 atoms here. So I'm going to come here, get my carbon, make that guy carbon, clean up, add hydrogens. Now I've got butane. First thing I'm going to do is clean up, mechanics optimize, and I'm going to say, all right, so in butane, I'm going to look down this dihedral angle, right? Can you see that's the one I'm going to look down right there? Hopefully this model makes it easier than the book, okay? So there, can you see that these two methyl groups are as far, there's a methyl group right here, and here's a methyl group, and they're as far away from each other as they can possibly get, right? That angle right there is whatever, okay? So I'm going to select those guys, atom, no, I'm going to deselect him, atom, those 4, there's my 4 right there. And you can see, no, atom, 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 and atom, okay? You can see that they're as far away from each other as they can get, right? All right, so let's go back here. They're still selected. That ought to be 180, okay? So it's obviously very close to 180. Let's make it 180, okay? And we're going to calculate the strain energy, okay? So the strain energy is 2.1714 kcals per mole. Better write that down again because my battery's going dead. Here, ringing funny. 2.1714. 2.1714. And what is it if we make it 60 degrees? Okay, so the way I'm going to do that is I'm going to come here, and I'm going to go, let's make it, well, not 180. We need to step by 60, so I'm going to make it 120. Okay, return. And you can see I got some twisting at that bond right there. Look at that. So now, aha, these guys are eclipsed with hydrogens now. Can you see that that is eclipsed with a hydrogen? And this is eclipsed with a hydrogen right there. There's the angle I'm looking down. There's the bond I'm looking down right there. So my dihedral angle now between these two methyl groups looks like that's actually 120. Yeah, you can see that. It's 120, right? 120 degrees in a circle. You can tell. So let's calculate the energy, strain energy, and it's 5.6267. 5.6267. Okay? And it looks like it's also about 14.5, right? Oh, actually, the last one was 19, wasn't it? So it's about 14.5. So this has to do with probably the molecular mechanics. But either way, watch this. Now we're going to make those methyl groups eclipse with each other. Watch. Okay, now I'm going to take them and I'm going to go. I want those guys to be at a 0 dihedral angle. Okay? That's going to bring them all the way around. Okay. Watch that. You see how those methyl groups are eclipsed with each other now? Boom. Ooh, they don't like that. No. No, no, no. I do not like that. It's eclipsed. Let's see what the energy is. Calculate. Strain energy. No, I don't want that. Yeah, I want strain energy. And it's 10.1983. 10.1983. I think that was the year I got my first kiss. 1983. So, and where am I here? Think about that first kiss. All right, so I don't want to do that difference right now. I want to do, let's come over here. What was it? I really lost track of my thought here. It's 10.1983. 10.1983. Okay, now the difference between this and this, look at that, equals this minus that is a lot. Right, where the methyl groups are completely away from each other or perfectly eclipsed. It says about 34. What does the textbook say? For butane, nah, not even close, right? Look at that. Totally eclipsed and totally staggered. So this only says 20 kilojoules per mole. All right, so we're definitely using a different force field for this, this calculator on here, the molecular mechanics calculator. But you can see, though, if I make them partially, that, by the way, that's called gauche right there, where they're not exactly eclipsed, but they're closer. Can you see those two methyl groups are closer to each other? Here they're further away. Here they're right on top of each other, and there they're next to each other by 60 degrees. So we could calculate that all the way through. This is probably the accurate one, 19 kJs per mole. They probably didn't do this computationally. They probably did this experimentally, and computation, which I'm a computationalist, but computation is hobbled by different assumptions that you make, and so there's always that question to be asked. All right, so I think that's all we're going to talk about with respect to conformational analysis. So we talked about We talked about configurational isomers or constitutional isomers, or yeah, I'm sorry, constitutional isomers. Now we're talking about conformers. That is, these two molecules are conformational isomers with respect to each other. That is, they're the same molecule, but they have different conformations. All right, we will be back soon with more to practice. Hope that was helpful.